Okay, good morning. You can use the chat box to say good morning since we're not sharing the microphone. And yes, thank you. Thank you very much. I'm just looking at my other screen. And also you could, I will probably switch off the video. I like to see you. I mean, you can see me just for few minutes because the video, I mean, the window is covering the slide, which we actually need the full slide. And also the internet connection is much better if I switch off the video. That means also I would like to ask everybody to switch off the video, the camera. It's just, I mean, I love to see my students, to have the eye contact just for a little while, but if you can, I think I can help. Who has the video? I can, okay, you can stop the camera. Okay, I will stop that video. And we do have one more. Inger. Stop the video. Okay. And I will stop my. Okay, that means one more time, welcome to week 3 of calculus class. Mute the microphone, please. Janelle, can you switch off? Yeah, thank you. I'm just trying to set up, yeah, one more mute. Okay. That means this is lesson 2, and we just finishing chapter 1. That means you can see that's the topics this week. We will still talk about the exponential and natural functions, natural logarithmic function, which we touched a little bit last week. Since we know that many quantities in nature change actually respectively to the exponential growth or decay. Okay. We will also talk about creating a new function from having some old functions, old models. Also, we will talk about the functions that they are proportional to each other, and we do some nice periodic phenomena in nature, which most likely we will talk about. The periodic functions are the trigonometric functions, trigonometric rate. And that means let's see what we have. I just collect a few important questions. Oh, is my internet good? Okay. One more time. I have some important questions from each section. That means I'm really hoping this will be helpful for your weekly assignments, weekly quizzes, and later for the midterm and the final. Okay, that means let's learn these concepts. What we have. First of all, logarithmic function. That means we remember from pre-calculus how logarithmic functions are defined, and especially natural logarithmic function. I'm just trying to mute the microphone of all of the attendees. Okay, that means natural logarithmic function, we know that this corresponds to the base e. Okay, that we can see ln is the notation. That means ln of x means natural logarithmic function of x equals to c. And definition, follow the definition, we do have the e, the base, to the power of c is giving me x. Okay, back. Oh, of course, that's the meaning, but we're not really writing, we're not really using this notation. No, we're definitely using ln if the base is e. And we do have some properties. When we're adding two logarithmic function, we can multiply the inputs and have one single logarithmic expression. Subtracting means that we're dividing. This is quite helpful, and you're probably using a lot this property, not even thinking. Okay? Like if we have the natural log, I mean any log of a to the power of p, that p can travel in front of the logarithm. Yes, we can see, we can kind of take the p-value, or if this is going to be unknown, which you can see in a minute, a few questions, that we can take it out from the exponent and have the product, and then it's easy equation. Yeah? Like, and especially the property 4, which is identical. Yeah, 3 and 4 is identical, because having ln of e to the power of x, I can put x in front of the logarithm, right? That's the property number 3. And we all know that natural log of e, it's 1, because e to the power of what number to get back e? That's the reason that we like to take the natural log of both sides. But ln of e to the power of x is just x. Okay? And this is the same thing. This is the property number 5. It's called cancellation equations, because when we have exponential and logarithmic, that's the inverse to each other. Yes, exponential and logarithmic, they cancel, and the input will stay only x. Okay, that means it is worth to know that logarithmic function at 1 is always 0, and I was gonna box ln of e is 1, which I just wrote above. Okay, and that's the function. That means to solve exponential equations, we can see this, we will most likely use the logarithmic form. Or having a logarithmic equation, we can always rewrite as an exponential form and solve it. That means, let's see what I have. I do have one question. Okay, I took from the textbook, and it's just, yes, just the exponential equation, but I think we have to use the logarithms to solve it. 40 equals to 100 e to the power of negative 0.03 t. As you can see, t, we have to solve it for t. I have to take out t from that exponent. That means, first of all, I think I will divide both sides by 100. Okay, and this one is 0.4. And we can see that's the moment that I can take the natural log of both sides. So I'm taking ln and ln. Actually, I can use 0.4. It was, but I know that most of you, or maybe even everyone, knows that the ln and e is gone. We will have only the exponent. This will stay. Okay, that we can see ln of e, the exponent travels in front. But of course, ln of e is simply 1. That's the reason that it's gone. Okay, now I have a normal linear equation. I can just divide by negative 0.3 both sides. That means my p-value is natural log divided by this quantity. And we can leave it like that. Because I'm assuming that most of the tests, I mean, we may use calculator from time to time, because of course, especially if we have some applications, would be nice to know what the t-value is. I don't know if we really feel this quantity, okay, but I will leave it for a moment. I have calculator somewhere, but I can leave it. Because if we have on the midterm test and the final test, we are not allowed to use the calculators. Okay? That means this answer will be fine, will be sufficient. Okay, that means that's the solution of the logarithmic equation. I mean exponential through the logarithmic. And I do have one more. As you probably know, somebody asked for this question on the discussion board. Okay? That means I really like that you're asking questions. And I think I typed the solution, but let me just solve it again. Or maybe I can even solve, maybe I typed different way that I will solve it now. Because you always have a little bit different ways. Okay. That means this is, again, exponential equation, 7 times 3 to the power of t. equals to 5 times 2 to the power of t. And we have t in both places. We have to combine them together and also take it out from the exponent. That means the first step, I will divide both sides by 5 and both sides by 3 to the t. Right? Because if I divide both sides by 5, 5 is gone on this side, 7 over 5. If I divide both sides by 3 to the t, 3 to the t is gone, and it's on this side. And then I do have, let me put 7 over 5, and I can combine this. Okay? And now the only thing that I have to do, I have to take the natural log of both sides. ln, I wanted to point. Okay. I can copy this, and now we know that t can travel, t can be placed, we can put t in front of the logarithmic function. In order to solve for t, I have to divide both sides by natural log of 2/3. That means t is equals to ln of this, ln of this. It looks a little bit weird. I think I did found the value. It's negative 0.8298. Of course, I did use the calculator. You may try later if you can use your calculator to get that value. Okay? That means this is negative because we can see we have ln of the number less than 1. Yes, that's the reason that the value is negative. Function natural log y(t), ln at t. This is 1. That means number which is less than 1, it's somewhere here, and the corresponding value, it's negative. Okay? I don't know the value, but that's the reason that makes sense, the negative answer. 7 over 5, it's greater. 7 over 5 will give me positive output. Okay? And this, that's we can always like think if this makes sense. But again, probably this answer will be good. Okay, that means that's the combination of logarithmic and exponential forms. Now, let's see what else we have. We do have, as I mentioned, lots of quantities in nature behaves like that. That means we will have exponential model, exponential function, natural exponential function because the base is e. And what we have? We will have some form, some exponential function written in this form. P equals to p sub 0 a to the power of t, or equivalent, p equals to p equals to p sub 0 e to the power of okay, I have some feedback because I was trying to okay, one more time. P equals to p sub 0 a to the power of t, which I think we remember something from last week, and p equals to p sub 0, the same p sub 0, e to the power of kt. That means now we know that if looking at this form, okay, if the exponential function has a base greater than 1, it's always increasing, will be the exponential growth. If it's less than 1, of course, positive, greater than 0, we do have exponential decay. We may also have something like continuous growth or decay, which k is the continuous growth of decay rate. Yeah, we have a little bit different. We will compare these two functions in a minute. I do have a question. Because the rates are comparable. And the same thing, if that coefficient k, it's positive, if it's greater than 0, positive, it's always exponential growth. Because it will be e to the power of 1, 2, 3, 4, 5, 6, whatever positive number, or even, of course, the fractions. If k is negative, we do have exponential decay, because we will have, for example, e to the power of -1, -2, -3, which will be less than 1 as a base of the exponential, which we remember, if the base is less than 1, function is decreasing. And that we have to remember both of the formulas and know how to compare them. I have a question for this. And also we will talk about the doubling time and half time of the increase, of course, or decrease, growth or decay, and a little bit of compound interest. Okay? Like if the interest is compound like annually, or if the interest is compound continuously, then we're using always the logarithm, the natural exponential function. Okay, that means we have like 3 topics. You can probably pause that video pause on that slide and come back treat this as a reference page. Okay, let's see, because I would like to focus on the questions. It's more effective for the students. Okay, let's see what we have. What is the continuous percent growth rate for the function p equals to 100 times e to the power of 0.06t with time t in years? And that we can see, we recognizing right away. I can write maybe the equation. It is k times t. That we can see p sub 0, the initial amount, the initial number is 100. That means this is 100. And k, it's 0.06. Okay, in this case, which this is the continuous percent growth rate. Okay, I don't want to copy the whole. Okay, that's, which actually I can write this as a 6%. Maybe that's better, because we know we're dividing by 100 when we using in the equation. Percent is not really, it's just like dimensionless. It's not really like a unit. Okay? But 6%, that's the continuous percent growth rate. Okay, that's it. Now let's compare the continuous percent growth rate to the annual percent growth rate. Let's see if they are the same, because we will use exactly the same equation. We will just rewrite to the form of p sub 0, a to the power of t. And what do you think? The rate that I will try to compute, I can possibly write, this will be p sub 0. And of course, this quantity a, it's like 1 plus that rate. Yes, to the power of t. Because we know if it's 1, it's just 1. But the rate, if it's addition, it is growth. If it's subtraction, it's the decay. That means, what do you think? In order to have the same output, the annual percentage growth rate supposed to be higher or lower? Because this rate, it's like we're using this rate in order to compute p. We're using this rate constantly, like continuously, almost every single second. This one, we're not computing the rate like all the time. We're just computing like once a year. Let's say this way, annually. That's what do you think? The R that I'm gonna compute, it's gonna be greater than 6% or lower? Since I have to match up with that number. That means it's gonna be. Oh yeah, no, we're still thinking about because 1.6 is 100. It's more than 100. I'm still thinking about the number like a rate as a percent between 0 and 100, of course, when we're talking about the percentage. That means you, Ryan, you said probably exactly the same, 6%. because writing 1.06, I think means like that the growing rate was 6%. Okay, that means could be the same, but we have to think, because you can maybe think in terms of investment. If you will invest P sub 0, if you will invest, let's say, even $100, and somebody will compute your interest constantly, that means you, and with of course with that rate, you will accumulate a certain amount P, right? But if somebody will only add the interest to your amount once a year, you will not compute that the same amount. That means what's happened, in order to get the same amount after 1 year, that rate must be a little bit higher, okay? Because we have to kind of match up this continuous calculation. Okay, I'm just trying to show you that, like, yeah, the meaning. But let's see, we can always compute and then we can compare. I hope we will get higher rate. That's what I'm trying to do. I'm trying to tell you that this formula is the same like this one. That's actually T. P sub 0, of course, is the same. It must be the same, 100. That's when I am dividing. And I have a to the power of t, and I have e to the power of k actually was given, also to the power of t. That means now we can see on the left-hand side, I do have a taken to the power of t, a. On the right-hand side, I have e to the power of 0.06 taken to the power of t. That means these blue boxes, they have to have the same value, which is a is equal to a to the power of 0.06. And I did use the calculator, and I've got the number 1.0618. Okay? Which this means the rate that we're adding is, yes, close. I know. Yeah, it's good, like understanding. 0.6. I kind of knew that must be a little bit higher, but I'm always, even if I kind of know this and I understand, I'm always thinking that this rate is supposed to be bigger, yeah, because this one we're computing like constantly, continuously. This one we only computing once a year, but it's just, yeah, it's just like it is. That means the annual, yes, thank you. That's what I'm trying to, yes, to show you. That means the rate I can probably put, which will be the annual. Oh, can I do the annual percentage rate is just 6 point, it's just from here. Okay, that means we can see the continuous is 6%. This one must be higher because we have to match up the same amount of dollars, let's say. Okay, I can keep this. That means that's how we can compare continuous rate of percentage growth rate and the annual percentage growth rate. Okay, thank you. Let's keep moving because we do have, I think I have 14 problems. Okay, it will be good motivation factor to stay with me and participate. Now, this is number 3. Let's see. Of course, if you have a question, please ask anytime. Okay, and you can type on the chat box, and I will be more than happy to help. Okay, now, another like exponential, logarithmic, or some application. Okay, the quantity p is an exponential function of time. P equals to initial amount P sub 0 e to the power of kt, which of course is the continuous percent growth rate, k. And we do have some information. If the output, if the quantity p equals to 140, then time is 3. And that's probably this means that after 3 years, I've got the amount of $140, I can say. After 1 year only, we can see if t is 1, I only have 100. And the same equation, the same model. That means what they're asking me, I have to find the parameter k, which is the continuous percent growth rate, and I have to find my initial amount, the initial amount that was invested. Again, thinking about dollars is always the easiest way. That means let's see what we can do. First of all, let's create an equation, or possibly a system of two equations. If the output is 140, my initial amount, I don't know, e to the power of the rate k times 3, because it was 3 years. If my output was only $100, investing the same amount, p sub 0, the same percentage, percent growth rate, but only for 1 year. That means just what was said, I did create a system of two equations, and I do have two unknowns, k and p sub 0. Okay, let's try to solve this equation for both of them. That means first of all, I will solve the first one for c sub 0, dividing both sides by e to the power of 3k. And the same I did for the second equation. That means the initial amount is defined like that, and both of them are the same. I think I can compare them. Okay, 140 over e to the power of 3k equals to 100 over e to the power of k. I can cross multiply, but maybe I can divide by 10 at least. Dividing by 10, 1 zeros on both sides is gone. Okay, cross multiplying, I will get 100 times this, 14 times this. I can divide by 10, 1.4, and I can divide by e to the power of k. I can write this, because normally I'm not, I think I'm losing a little bit of my internet. And this will be 3k minus k, 2k. Okay, now if I will take the natural log of both sides, I am losing e, the base e, and then I have to divide by 2. 1/2 ln of 1.4. I can maybe write here 1/2 natural log of 1.4. And did I use the calculator? I think I did use the calculator. It's 0.168. Okay. That means this is like 16. Oh, that's big, right? Or maybe I am wrong. It's like 16.8%. Okay, quite big growing rate. Or maybe I'm missing a 0. No, I think it's, if you have a calculator, you can check. But maybe that's the growing rate, because I'm just trying to check again. You can type 1.4, and then you can take the natural log, and you can divide by 2. No, that's correct. Okay, that means that's 16.8%. Okay, and now that means we do have the quantity, the parameter k, and we have to compute p sub 0. That means p sub 0, what I can do, I can take this equation or I can take this. Both of them should give me the same output. I think I will pick this one. The second one looks just a little bit easier, because it's 100 e to the power of 0.168, and I also compute this one. This one is 84.58. And as we can see, that's the initial amount. When let's say when I invest this and have all of this, the whole scenario, I will get $140 after 3 years, $100 after 1 year. Okay. And now you will answer the question B. Okay, that means now look what they're asking. State the initial quantity. That means what is the initial quantity? Do you see the answer on the screen? Because theoretically, question A and B, part A and B is exactly the same. They're asking for the same things. That means what's the initial quantity? Can you just, yes, yeah, thank you. This is simply the initial quantity is simply P sub 0, which I did compute. And what about the continuous percent growth rate? I think we have definitely a growth. It's yes, exactly. This is K. And I also, I don't like crossing. Okay, I will cross it. It's K. That we can see that they just trying, probably this question is just testing you if you understand what K means and what P sub 0 means. Okay? I mean, that's P sub 0, that's K. Okay, that means we should be, I hope we should be okay with this type of equation. Okay, let's keep moving. I think I have 1 or 2 more because we also talked about, okay, another investment, which we will use the same, yes, the same equation. We can see once a year and continuously. That means continuously will contain the E number, the natural exponential function. This will be the general exponential function. Okay, that's what we have. We do have $1,000 and we're investing in the account, paying interest rate 5.5% per year. How much is the account after 8 years if the interest is compounded annually or continuously? Okay. That means this one is just my initial amount and it's the quantity A, but I will split for the rate and the time. I don't know what I'm getting. I know that I am investing $1,000 and my rate is 0.055 and number of years. You can see nothing to think. Yeah, it's almost plug in the numbers, but we have to know the first equation. Okay, that means this is 1,000, 1.055 to the power of 8. And I did use the calculator, $1,534. Okay. Not, yeah, the rate is quite small. That means we kind of like, we almost double. I mean, we did double the money, but after 8 years. Not bad investment. Let's see now what will happen if the interest is compound like continuously. That means this what always like worries me, because I always expect much bigger amount. Yes, I hope we will have bigger, but it's always not big difference between these two. Yeah, that's also something that we can think deeply about the mathematical like steps. Okay, what is the equation? Initial amount E to the power of time times rate. $1,000 E to the power of 8 years, and the rate is 0.055. Okay, I did use the calculator and I do have an amount $1,552, and I even have this one, 71 cents. Yeah, that we can see it is bigger, but, and it is definitely correct. I did like this type of questions I was trying to solve like when I was a student, even for like I was trying to understand, because again, I'm always expecting more. Yeah? But mathematically that's how it is. Okay. Let me please make sure I can box for you. Make sure that you remember this. And make sure that you remember this. Okay. And I have, I think, another one. Okay, the doubling time. or the, I think I should also have, do I have, oh yeah, doubling or the half, but let's do the double. Calculate the doubling time D for interest rate 2% per year compound annually. Okay, that means what we have, since this is annually, we know what formula to use. Amount, initial amount, 1 plus the rate to the power of t. Okay, and now, okay, the doubling, calculate the doubling time. I'm just trying to, it should be t. Why I have d? It's, yeah, it's okay. We have to just, what we have to do, we have to find t, time, yes? We have to find, like, we find the doubling time on an interest rate, 2%, okay, per year, of course, using this formula. And that means we will find the time that the investment is double in value. Okay, because I have thousands of thoughts in my head. That means what we can do, since we don't really know what is the initial amount, I would like to show you something. Like, let's say we're investing $1, okay? And this will be my rate, and that's my time. That means if I'm investing $1, what amount I will have, what will be the output? Can you, of course, 2. It will be like two times that $1. Okay, and if I will, yeah, that's okay. That means I can even ignore, I can divide by 1, which of course is pointless. I will end up with the quantity 2 on the right hand side. Okay, now can you tell me, if I will invest $10, what will be the amount? That I am expecting 20, of course, because I do have a point. And now if I will divide, if I will divide both sides by 10, again, I'm ending up with 2. That means my point is to tell you that doesn't really matter what is the amount that I'm investing. If I am doubling that, I mean, doubling the time, this means that I'm doubling my investment. I mean, the investment is doubling. Okay, just here, let's focus on this, doubling. That means I'm in always double, I'm expecting my investment to be double. That means if this is, let's say, 5, this is 10. If I will divide by 5, I will have 2 on this side. Okay, that means let me put 1, let me put 2, and always the equation will look like this. I mean, always 2, right? Always 2 when it's double. Do I have some? I think yes, I did. I don't want to come back. I did have the theoretical part. Okay? That means even if we put, like, I don't know, 100, then this will be 200. If we will put, I don't know, 5,000, this will be 10,000. Dividing, we always end up with 2 on this side. Doesn't really matter what is the investment. That's the point. Okay, and now I believe everybody can solve this equation, taking ln of both sides. Okay. T, of course, can be placed here. And we can divide both sides by ln of 1.02. And since we're looking for the time, I did use the calculator and I did get 35.003, which of course, if we're talking about the years, it's 55 years. Okay. That means we can see with the annual interest rate, one more time, 2%, it takes about 35 years for investment to double in value. Okay, that's what I mean. But please remember, even if the amount is given, the amount of the investment, you will always end up with 2 because it's double. Okay, that was my point. And remember, equation corresponding equation. Okay, now let's see what I have. I have this one, but since, hang on, I should have, we will come back to this because that's our question, but this one is more mathematical. Oh yeah, I was looking for this one. That means this is the same like the present value and the future value. It's almost what we did. Like a p sub 0, which your textbook is using like a b value. I mean, present value is p. That means p sub 0 is p. We can see the equation. That means just different notation, but doesn't mean that we have to like follow the labels. Present value is the value that I have. Future value is the value that I will get, okay, after some investment. That means let's maybe solve another 2 problems with the future value and the present value, which I can show you we don't even have to think about because that's from your textbook. That means don't worry if you understand, yes, what we're doing, where the investment money should be placed and where is the expected number, the future value should be placed in the equation. If you understand this, that's fine. And that means, let's see, find the future value, which means the amount that we're expecting in 15 years of investing 20,000 today. If the interest rate is 3.8% per year, compounded, and see, that's the point, continuously. Do you think you can tell me the equation, just the equation? I will just check if you learning something today. You remember my equation? It's different than annually. And I can use my old p sub 0, okay? Because I don't want to confuse you. Okay, you remember p sub 0, and what shall I do here? It's this one will be 1 plus r to the power of t. I can come back. Can you see? That's we have to be, actually I have better slides. Annually, that's what we do, yes, continuously. Compound continue, that, yes, thank you. I mean, we can always make some mistake, it's not a problem, but please remember, come back to this slide. Remember this one, annually, and remember this one, continuously. Okay, I will come back, but still good, yes, good try, 50-50, and we can see it's the same things, but we don't, this one and this one I was trying to. Okay, that means what I have to do, I have to add e to the power of RT. Okay, and my future value, which this will be in my labels, how can I do? That's the future value, P. Okay, I'm investing 20,000 and the rate is 0.038 and the time is 15 times 15. Okay, and we have to use the calculator. The amount is $35,365.34. And that means that you can probably check, you can get this amount, you can take E value to the power of that and multiply by 20,000. Okay. But again, the point is, remember the formula, because when you use different formula, you will probably get a little bit different, a little bit less. Do you remember? If it's annually, it's less. That means that's what we have to do. And now let's compute, because we did compute future value. Right? Future value. Let's compute the initial amount, find the present value of 8,000 payment to be made in 5 years. That means you will get $8,000 in 5 years, but what was the amount that you invested? Okay, what was the present value? The interest rate was 4% per year, compound continuously. Again, continuously. One more time, who can tell me the equation? I will use my present value is P sub 0, okay? Who can tell me the equation one more time? You can type it again. And you did, if you, the same, thank you. The same like yours or the same like mine from the Andre? Is the same like you type it? Like, okay. Or like Maddie typed, okay. Okay, e to the power of RT. I was trying to point present value. Okay, that's what I'm doing. I'm getting 8,000. I don't know what I invest, but I know that it was 4% 5 years. That means I will divide both sides, which means I will divide 8,000 by e to the power of, actually 4 times 5 is 2.2, because we will have 20. Okay. I did use the calculator and I do have $6,549.85. That means after 5 years, we didn't double, like, but we did invest $6,500, okay, approximately, to get 8,000 after 5 years. Okay, not bad. 4%. That means just, yeah, I'm just trying to show you that even if your textbook is using different notation, doesn't matter. Don't be like confused. Always remember about that exponential model. Okay. So now I think, because I do have, I have another question, because I wanted to come back to that table because somebody emailed me that had this question, but let's solve this one, because I think I have one more. Let's read. A population of bacteria growing exponentially can be modeled as P equals to P sub 0 e to the power of KT. Of course, we're not surprised with the model, where T is the time in hours and P sub 0 is the initial population, initial amount. If the population has a doubling time, of 4 hours, calculate the growth constant, K. Okay, that we just have to take the same equation, but we will calculate different thing. That's what we have. We do have an amount. We do have P sub 0 e to the power of KT. And we know that the growing, we don't know the rate. We don't know the rate, but we know time. We know that this doubling time is 4 hours. That means 4 times T times K. Let me put nicely for you, K times 4. Okay? But what do you think? Can you tell me what shall I put instead of P sub 0, or what shall I put instead of P? Because we're talking about doubling. Of course, it's doubling time, but this means it's 2 and 1. Of course, if this is 1, I will double. And doesn't matter if I will put 100 or 200, 500 or 1,000. You learn that, doesn't matter. 1 and 2, of course, is the basic, the best numbers. Okay, I can rewrite without 1, and I can take ln of both sides, which of course we know that this is 4k. K. This means k is ln of 2 over 4. And if you use the calculator, we will get 0.1732. Right. 17.32%. Quite big, but my 7. I mean, I do write 7 like that, but let me write a little bit better. Okay. That we can, again, I'm just testing this for you and how to solve exponential. Yes, how to solve the equation if the unknown is placed in the exponent. Okay, I think you understand this. That's me now. Let me come back. I will come back to this one. Because we remember from last week, I was trying to show you how you can recognize based on the values. How can you recognize that the function is a linear function? just like a line with the constant slope. Now we do have a few functions, okay, and we have to find out which one is the exponential. Or maybe we can't find the relation, then we will say the function is not exponential or power, exponential and power. That means consider the 4 functions given in the table. Each one may be power function, exponential function, or neither. Okay, that maybe we will not get any relation. And I type this for you. Of course, I can tell you, but especially for the exponential. If your input values are evenly spaced, which it is, this is input, 1, 2, 3, 4, 5, that's input, x. Actually this way, right? I can point. Actually, it's exactly equal to. If x is 1, 2, 3, 4, 5, 6, okay, that we do have evenly spread inputs. Then the quotient of the consecutive outputs values will be constant for the exponential function. Okay, that's how we can figure out the exponential function. Let's look at the function f of x. F of x is defined like that. For 1, it's 1. For 2, it's 4. For 3, it's 9. For 4, it's 16. Actually, do you see the pattern? How function f of x is defined? What's the formula? Okay, we can see, in order to get 4, having 2, or maybe let me ask this, because 2 is a little bit weird. In order to get 9, having 3, what you will do? What you will do with the input 3 to get 9? You will square that number. Thank you, Adam. Yes, Christine, thank you. You will square 4, 16. You will square 25, of course. Yes, we can see how nice and easy the values are. That means this is definitely, that's the power function. Okay, we do have a power 2, power. Okay, let's look at g of x. 2, 4, 8, 16, 32, 62. It's definitely not, oh, actually, do you know what? This should be 64. I really wanted that pattern. That we can see it's not really a powers, because power 2, 3, it's not really. But what we do, let's check this. That means if I will divide 8 divided by 4, it's 2. What is 16 divided by 8? It is 2. 32 divided by 16, it is 2. And that we can see, this is like the quotient is constant. That means I think it's simply 2 to the power of x. 2 to the power of, this is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. Okay, because when I divide, always I have to multiply by 2 to get the next term, which means if I will divide backwards, I can get the constant quotient, 2 to the x. Okay, what about h of x? 1, 8, 27, 64, 125. I don't know if we recognize the numbers. Again, what do you think? It's 4x. Let's look at this one, 27. 27 looks like, and 4x, if I will multiply 4 times 1, I will not get 1. Oh, yeah, I think Adam, yes. What Christine said, that makes sense. G of x is x. Yes, that's exponential. Oh, yes. If x is placed in the exponent, it's an exponential function. Correct. Okay, let's go back to h of x. I think Adam, it's correct. It's yes, no problem, Christine, no problem. That means h of x looks like my quantity 1, 2, 3, 4, 5, 6 to the power of 3. So let me place just this one, exponential. That means it's 1 to the power of 3, of course, 1. 2 cubed, 8. 3 cubed, 27. 4 cubed, 64, and so on. Yeah. Okay, and we do have the last one. let's see, 6, 12, 24, 48, 96. Looks like I'm doubling the amount. Can you see if I divide 12 times 6, it is 2. 24 divided by 12, it is 2. 48 divided by 24, it is 2, and so on. That means, look, since I am like multiplying my constant multiple, I mean my quotient is 2. That means I'm assuming that is again exponential function 2 to the x. But something is not right, because 2 to the x was my second function. 2, 4, 8, 16. That means what correction I have to make to get the exact formula. Okay? Let's try, because this is definitely two parts of this function. It's definitely 2 to the x. The main one is definitely exponential. Okay? Let's look at the first one. If x is 1, okay, let's take the value at 1. 2 to the power of 1. 2 to the power, because I'm just trying to, I think I have extra coefficient. 2 to the power of 1 is, of course, 2. What number I have to take and multiply 2 by to get 6? Because we can see the first value is 6. The second value is 2 to the power of 2, and it's 12. That's me, right? Thank you. It is 3. And I believe this will work for all of the numbers. That means this function is 3 times 2 to the x. And we did figure out based on the numerical numbers, numerical values provided. Okay, that means I think you should be okay, especially with the nice power functions. And the point is, because that's the new topic, exponential. Okay, let's see what else. Question 7, we did. Oh, my answer 6, 7. Oh, I think 8. I messed up my numbers because I was playing around with the. Okay, that means we have 5 more problems. Question 9 up to 14. Okay, that means this one is different. This one is a different section. This one is the section that we will talk about one function, having one function and creating another function. Okay, that's mean getting a new function from the old function. And we have to know what this notation means. That means what we have. We do have a function f of t defined like that, negative root t over 6. We have g at t defined as an exponential function 4 times e to the power of negative 2t. And now we have to calculate f of g of t. You may probably see this notation, which means exactly the same. F is compound with g, f is the inner function, and g is the output to the f function. That means let's try. My function f, the outer, f of, oh, I should actually put t. Why I put x? My function f of t is defined as a negative square root of t, but now I don't want a t. I would like to put g of t, and over 6. Yes, we can see it's not f of t, f of g of t. Instead of t, we have to put that one, g of t. Okay, that means let's just do it. 6, and the g of t is defined as a 4 e to the power of negative 2t. Done. I can simplify, but it's definitely the good formula. Square root of 4 and square root of e to the power of negative 2t, 6. Square root of 4, of course, is 2. 6 divided by 2 is 3. And I can also simplify this one. I don't know if we can see this, because this is like e to the negative 2, and it's squared. And if I will take the square root, we know that square root and square is gone, because square root is 1/2. That means this one, I can simplify to this. That's the final, oh, I didn't want to cross it. That's the final question, answer. That means I did simplify 2 and 6, it's 3, and I did simplify that square root. Okay? But that's important to know, okay, that instead of the inner function, it's just the second function. I think I have similar question, but just playing with the values. Having two graphs, this is f of x, this is g of x. We have to estimate g of f of 2. That means, first of all, I will make sure that we know where we are. This is the y, that's x. Y, x. Okay. And please remember, never put the arrows in the other direction. We only pointing in the positive direction. Okay, that's just a small comment. Okay, that's what we need. We need g at the value of f of 2. That means, first of all, I have to find this value, f of x2. Let's look. This is function f. 2, I believe, is here. That means the corresponding value, it's here. Let's say half. That means this is g at half. This is half. Now I have to look at this graph, take the half input, the x equals to half, and get the output. That means I believe that's half, and I believe this is the output. 1, 2, 3, 1.5. And that means that's how we can see we're using one value, one function, and then another one. That's different way of using like the new, creating a new function having two different functions. Okay, that's this. What else we have? Okay, we do have almost the last section, which is the last section talks about the periodic functions. Okay, that means we know that we will just focus, because we can create lots of different periodic, like repeating functions. But we will focus on sine of x and cosine of x. Just the trigonometric ratio, sine and cosine, because they are nice periodic waves. And what we need, in order to analyze, we will need to know what is the amplitude and, of course, what is the period. That means an amplitude is the half, the difference between its maximum and minimum value. And as we can see, how nice definition, half the difference. That we can see if the function is placed between 1 and -1, what is the amplitude? Can you tell me what's the amplitude? It's 2 or -1. It's looking at the, it's 1, between 1 and -1. We can see it's half, always the half difference. It's, oh, no, it's the difference. I know, it's probably so easy question, but, and maybe I think that the definition is easy. But okay, that's what we have. We can do mathematically. That means maximum value is 1, okay? Because we can see we have to take a difference between maximum and minimum. Okay? That means this is maximum value minus minimum value, and take half of this. Okay? I'm just following 2/2, of course, is 1. Yes, thank you, Christine. It is 1. Or we can kind of look graphically if we have the wave, I mean if we have the sine curve, we can take half of this and we can see it's 1. Yeah, that's the amplitude, like the peak. Okay. Doesn't really matter that it's this number. We will probably have different question in a minute. This is not this. It's just the difference between. It's halfway between the peak and trough. Okay, that we know the amplitude. Now, the period is the time for the function to execute one complete cycle. Okay, that's we can see. The sine curve is like from 0 to 2 pi. And then again, I can keep going. That means 2 pi will be the period. It's one complete circle, and then it's repeating. Okay? Or cosine. And we do have a few formulas. I will make sure that you know them. Okay? Because looking at the formulas, we have to kind of know what is the amplitude. Yeah, it's always that quantity. Yes, we can see 1 times sine, 1 times cosine, or maybe 2 times cosine will be that number. The period will be 2 pi, because since the main period for the basic function is 2 pi, we will always divide by the coefficient b if we're changing the formula. And plus c is just the vertical shift, up or down. Yes, thank you for telling me this, and enjoy the rest of your day. And yes, go back to work. You can check the recording, of course, Elena, of course. Yes, thank you for saying this. And yeah, I think maybe she left. Okay, I'm really hoping that this is helpful for you. That's when you can probably see what she typed on the chat, in the chat box. If you can print the slides, and you can maybe watch the recording, and this will be excellent preparation for your quizzes. Okay, that's what I want you to do. Yes, I want you to be successful and understand, of course, not just repeating. I always post, of course. I'm providing a link for the video, and I'm always providing these slides with my writing. I think I post them in each module. That means this is lesson 2. You can see, if you will open the modules, which actually that's our front page, just the last line, you will see like the lesson 2, like Kasia's notes. Okay, and then you can print them. You will have video, but I know that some students like just the slides too. Okay, yes, yeah, that you can also do this. It's good practice. Okay, let's see what we have. Okay, I copy from your textbook another functions, a few that we can see. This is the amplitude. It's just 1. We multiply by 2, by 3. That we're making the values lower, the highest value and the lowest bigger, and then we can squeeze the sine curve or cosine curve. That means the period will change. We can see we have sine of 2t. This means that from 0 to 2 pi, I have to squeeze 2 sine curves, 1 and 2, okay? Which of course I will divide my 2 pi interval by 2. It's pi, it's the period. Period is pi. And the amplitude is 3. And the same for here. 1/2, I have to stretch it. 1 is just the same. And 2, I have to squeeze it. 2, hang on, it's this. Oh, okay, this is 2. I'm just looking at 2 pi and 4 pi, but okay, this is still one sine curve, and this is the normal 2 pi. Okay, that means this is still good. Okay, that means let's see what question I have. I have this one, and I have one more. That means calculate the amplitude and period of the function. And let's see. We can see right away that the amplitude is 5. It's always that number. I will make sure, of course, that's maybe obvious, but if this number is negative, it's still positive. Please remember, okay? That means amplitude is 5, and we can compute a period. Period is always 2 pi over the quantity b. And looking at this, b is actually 1/4. 2 pi divided by 1/4 means multiplying by reciprocal. Actually, I can maybe keep in one line. 2 times 4 is 8 pi. Okay, that means the period, we can see it's really stretched, really long, like sine curve. And what -3 means? This will be a vertical shift. Of course, negative 3 means that we will go down. We will shift the entire sine function down. Okay, and maybe I can, let's focus on this one. Maybe let's get the graph of this one, because this one is too wide, but I can follow the same rules and I can graph this function. That's what we have. We have sine of 2x and negative in front and 5, positive 5. That we can see 5, it will be the vertical shift. We have to shift the entire function 5 units up. First of all, who can tell me an amplitude? Do you think you can tell me the amplitude? It's the coefficient, it's 1. I see number -1, but of course we're taking, no, 5 will be the vertical shift. Because I can rewrite this function as a negative sine of 2x plus 5. I know the way that it's organized looks confusing, but the vertical shift will be 5 units up. Okay. And who can tell me period? Right? It's 2x. 2x. That means I have to take 2 pi, because that's always, and divide by the quantity b2, which is simply pi. Okay, that means I will try maybe, I don't know if we really have to, but I would like to show you. That's what we have. We need a function sine, but this will be just halfway. Okay, that means this should be maybe a little bit, I mean, in terms of the values, maybe a little, okay, I can leave it like that. Okay, that means this is, I will do one more thing. Because what we have to do, we have to shift up. Okay, pi is the period, because I have to squeeze one sine curve from 0 to pi, because I did divide by 2. Now, hopefully you remember from your pre-calculus class, negative in front of the sine function. Do you know how this negative is affecting the graph? We have to make like a upside down. That means this will be negative. That means the blue one, it's negative sine of 2x. Okay, that means that's excellent. This is actually pi over 2. That's 0. And the corresponding values at the moment are 1 and -1. Okay, that means my blue function is negative 2x, and now I have to shift everything 5 units up. So let's try. I will use different color, green. If this is 0, this will be 5. This is 1, this will be 6. We can see. This is 0. 0 plus 5 is 5. And -1 will be 4. I know my scale is a little bit off, but I'm just trying. That's 4, and again 5. And as we can see, I took each green dot and shifted 5 units up. As we can see, the values are from 4, that's 4, to 6. That means having a graph, sometimes we will make the mistake and we will tell, 6 is the amplitude. Yeah, that means, no, 6, again, the difference between 6 and 4, maximum and minimum, is 2. 2 divided by 2, it's 1. That means the amplitude is still 1. Yeah, based on the definition. Okay, let's see. We have a question from Adam. Does the negative sign not get shifted as well? Oh, no, I did shift. Oh, thank you, Adam. I think I did shift the sine function. Oh, am I? No. We have to shift the blue function. Okay, this is my good point. I have to shift, okay. Let me put x's. I have to shift that point I have to shift this point. Thank you. And blue, I have to shift this point, and I have to shift that point. Thank you for, yes, I did. That's a little bit too high. I'm still writing too high. Of course, the blue curve. Of course, I did shift the red curve. No, we have to shift the blue one because we have negative sign +5. Thank you for, yes, good eyes. Yeah, I just focus on the normal sign. We do have to shift the negative sign. Thank you. Okay, but we definitely understand the amplitude didn't change because it's still maximum value 6 and minimum value 4. The difference 2, divide by 2, 1. And what else didn't change? The period. Okay, that's it. But of course, that's the correct graph. Okay, let's see what else I have. Oh, this one is just computing the amplitude. Suppose a quantity k can be modeled by the sine function. Yeah, you have to really watch me what I'm doing. Sine, let's say sine theta. But I think it's missing, I don't know. The maximum value over one period is 50, and minimum value is -20. That means maximum value, it's 50, minimum, it's -20. Who can tell me what is the amplitude of this function? What's the amplitude? Amplitude. Oh, 15. I don't know. Let's wait for everyone maybe to participate in this nice calculation. Maybe 15, but I need more confirmation. Or maybe not. Oh, somebody's writing. Yes, thank you. Thank you. I think this is the correct answer. Okay, I know where the 15 come from. Andre, I hope you can find your mistake. Do you remember the amplitude? Maximum value minus minimum value divide by 2. 50, yes, minus -20 over 2. Oh no, who the 35? I like this, the big 35. Who wrote this? You can write it again. Oh, I hope I didn't erase this. That means adding, let me put maybe the math, plus 20. 70 divided by 2, of course, is 35. Oh no, please do not erase this blue 35. That was actually good writing. Okay, that means please remember, do not make this mistake on your test. Okay, do not subtract. It's subtraction of the negative number. Okay, that's what okay. I have 2 more problems, and I promise I will let you go. You're really good. Thank you for staying with me. Okay, and hopefully you learned something. That's what I want. Okay, let's see. Another question. Find a possible formula for the given graph, and we have 2 graphs, A and B. Okay, first of all, do you think it's sine or cosine? Do you recognize, possibly? Always when we start at 0, 0? Yeah, what's the function? Let's name the first one. It's sine. Okay, that means it's sine theta, but I still need the amplitude, the quantity B. You can see it's not shifted. That means I can write this, right? Sine B theta plus C. C is definitely 0. Okay, who can tell me an amplitude? Can you tell me an amplitude? The amplitude. It's 7, thank you. We can nicely see. 7 and -7, this is 14, divided by 2 is 7, if we would like to think in terms of, okay, I'm writing theta, and this is 0 because we're not shifting. Okay, now the question is, what is the b value? Okay, what's the b value? Okay, now looking at the graph, can you tell me what is the period? What's the period? Can you see one cycle? Yeah, it's simply that one. No. One cycle is 10. And then I can repeat. Yes. It's going up and down. I mean, down and up. That's my sine curve. And it's from 0 to 10. And we also remember that period was, we did calculate as a 2 pi over the quantity b. Look how nice, we can compute the quantity b. I can divide both sides by 10, pi over 5. That means this is, oh, why I wrote this? Pi over 5. That means pi over 5, it's theta. This is my my coefficient b. Okay, that means this is the whole equation. Of course, we don't have to write 0. Okay, let's do another one. The same, a, and you can probably see it's the same shape. That means it's sine function. B, theta, plus the constant c. Okay, now what we can do? Amplitude. Who can tell me an amplitude? I think it's 3 because you can see that this is the lowest value, 0, 6. That's when we do have from the trough to the peak, we have 6. Divide by 2, it's 3. Excellent. Yeah, you do understand. Nice. Theta, and we need b, and we need c. B, we can probably compute the same way. Who can tell me the period? It's 8, thank you very much, it's that, because we have the full cycle from 0 to 8. And can you tell me the quantity b? Who can solve it for me? 2 pi over b, that was the formula for the period, is equal to 8. It's pi over 4, thank you. Really good. You see how nice you can compute this? Pi over 4, I will divide by 8. And do you think this function is shifted? Up, of course. How many units? You can see the original value is 0, 0, and now this value is here. Okay, the original value probably was, it's shifted 3 units up, of course. We can see 3 units up. The value was here, 3 units up. It's up, 3 units up. Okay. Yes, that means that's the formula. Really, yes, really good. I can box it for you. Okay, and I promise I have one last question because I think we didn't talk nothing about. Yeah, I have one last question. That means this is everything about the periodic functions. Again, if you will be confident with these problems that I solved, you're perfectly fine. Okay, but you have to understand. Okay, and I think one section before the periodic function is about the proportionality. That's what we have. We can simply have directly proportional functions or inversely proportional functions. That means if, let's say, y is directly proportional to x, if there is non-zero constant k, such that k multiplied by x will give me y. But we can see this is the direct proportionality formula. If we would like to have inversely proportional, we will just simply, do we have the formula somewhere? Oh, okay, inversely proportional, and y equals to k over x. That means x must be like we have to divide. K will still say k, the constant. Okay? That means I have only one question, and you can read it, of course, if the one is increasing, then other is increasing when it's directly If one quantity is decreasing, then the other will be increasing, or opposite for the inversely proportional. Okay, and I have last question, I promise. Let's see if we can get, it's a nice question, we will learn something. Okay, let me read. The blood mass of mammal is proportional to its body mass. The animal, I don't know, rhinoceros, I think. A rhinoceros with the body mass 3,000 kilograms has blood mass 150 kilograms. Find the formula for the blood mass of a mammal as a function of the body mass, and estimate the blood mass of a human with a body mass 70 kilograms. Let's see what we will have. We will have a body mass. Maybe I can name B. No, because we have B. Okay, let's say the mass, the body mass. Okay, it's because this is mass and this is mass. Okay, this will be the body. Actually, I just want the label. Body mass, and this will be the blood mass, B. Okay, that we can see the blood mass of the mammal is proportional to the body mass. Am I right? It's so simple, it's just a linear equation. No, we have to actually, no, we need, okay, one is, I mean, doesn't matter, blood. No, I need, no, let's say B is body. Am I right? Because the whole mass oh my gosh, I just want to write the formula. M equals to the coefficient constant of the direct proportionality to the body. That means this must be a, you can correct me, a body mass. No. And this will be the blood mass. Just the B. Did I say it's the easy questions at the end? And is this the right equation? Or maybe I am crazy. Because we have to take the body mass times the coefficient, and then we will get the amount of the blood. I think that makes sense. Okay, that means if the 150 kilograms, okay, we will get this blood mass, the blood amount, if we will multiply, I don't know the coefficient, but out of 3,000 kilograms of the body mass. Okay, that makes sense. Okay, because I have to, this will be a fraction. That means taking a body mass, yes, I am calculating and because they are proportional, directly proportional, I have to multiply by my coefficient and I will get the amount of the blood. That means now dividing both sides by 3,000, I am getting this coefficient. And I can divide 15 by, it is 1/20, which 1/20 I believe is 0.05. Okay, that means this is my coefficient of directly proportional function, the constant coefficient K. Okay, that means now let's see. My mass, I mean amount of the mass of the blood equal to K times the body mass. Okay? And I know that the coefficient is 0.5, and I want to find what is the amount of the blood, what's the weight if the weight of the human is 70 kilograms. Okay, that's M. We can multiply M again, M will be the blood mass. Okay, 0.05 times 70 you can help me because I didn't do it, but I can use actually fractions better than I can divide 75 by 2. So easy. 3.5 kilograms. I hope I didn't mess up. That's mean you can see that's what I wanted to finish. You see, if your weight is 70 kilograms, I don't know if you know the kilograms. It's like double. You have to multiply by 2.2 to get pounds. Okay, like 140 pounds. That's mean the amount of the blood, the weight of the blood is 3.5, 7 pounds. Okay, I think, yes, 7 pounds, or am I, yes, yeah, I think it's 7. Yeah, you have to multiply by 2.2. Okay? Or if you understand the metric, the kilograms, that system, for 70 kilograms, 3.5 kilograms. I think that's a lot, right? We carry that amount. Okay, this was, of course, just for the fun, the numbers, but that's important, okay? I'm sorry, I was just confused because this is mass and this is mass. Blood mass and body mass, and actually this is B and this is B, but I make this labels. Okay, just don't make. You will probably figure out if you will switch this, you will get this number huge. Yeah, you will get like, you will divide 20. That's not possible. That amount of my blood will be 20 times 70. Yeah, can't be bigger than my weight, and that you will probably figure out that something is wrong. But hopefully not. You will label this. That means this is just the really basic question about directly proportional functions. Okay, that means this was my last question. Again, thank you very much for joining me, and thank you very much for answering my questions. Thank you. It's really, really important. And I'm sure you did learn something today. Thank you.